Marhaba, hello everyone. So today we want to talk about functions. Remember that we are in the chapter about sets, where a set is a collection of objects, and we talked about operations we apply on sets to create or construct new sets. For example, we talked about the power set of a set, the Cartesian product, the union, intersection, and complement of sets. And today we want to talk about functions. Functions are very important objects in mathematics. They almost appear in every field of mathematics. They are also important in social sciences and exact sciences, where functions are used to model real life phenomena. Let me say that the notations we will use today about functions are due to Leonhard Euler, the famous Swiss mathematician. So let's start. So let me start introducing the concept of a function by a diagram. Okay, so the beginning is having two sets. Okay, let's have the first set A and the second set B. So a set is a collection of elements. So we have here the elements, and here we have other elements, say maybe more. Okay, now we want to define a function f from A to B. Okay, what is this function? A function f from A to B is an assignment which assigns to every element, say A in A, one and only one element B in B. Okay, so we have to assign elements to all the elements in A. This is one of the conditions of A. So here is a second element, let's call it X, then F assigns some other element here, let's call it Y, for example. Now here is another element U, say, and F assigns this element to U, let's call it Z, and here we have another element, say C, and F must assign some element to it in B, let's call it W. Okay, so this is the general picture of a function. Now let's write properly the definition of a function. So a definition: a function f from A to B. So this is how we write. F, small f, is the name of the function, and then we put a colon here, and then we say it's a function from the set A to the set B. Is an assignment or a rule, so it's an assignment where for every, okay, notice the universal quantifier here, for every element A in A, it assigns one and only one. Okay, this is very important. Element B in B. Okay, so this is the definition of a function. Now look here in this diagram, the function f assigns the element B to the element A. In this case, we write that f of A is equal to B. Okay, again, by this we mean that the function f assigns to A the element B. Okay, and when this happens, we say that B is the image of A. Okay, we also say that A is the pre-image of B. Okay, so look here at this diagram. A is the pre-image of B, and B is the image of A under the function f. Okay, let me say more, that okay, when we have a function f from the set A to the set B, then we call the set A, this set is called the domain of the function f, and this second set is called the codomain of the function f. Okay, now I want to define another set which is called the range of f. Before saying what is the range, let me explain it by a sketch. Sorry. Okay, so suppose we have the set A and we have the set B, and we have two elements, say in A. We have to assign images for them. Okay, now, and that's it. Okay, this is a function because for every element in A we assign one and only one element in B. And now if we collect, let me use a different color now. Let's say here is the blue. If you collect these, what are these? These are the images. Look, these are the only ones in B which have pre-images, or if you want, these are the only ones which have which are images of elements in A. Then this set which contains all the images is called the range of F. So the range is the set of all the image of elements of A. So look, it's the set of an image of A where A is an element in the domain. So this blue thing is the range of F, and of course it's obvious that the range, clearly that the range of F is a subset of the codomain of F. Okay? See, every element in the codomain is an element of B in the codomain. Sorry, every element of the range is an element of the codomain B. Now let's have some examples. Okay, so let's have the first example. So maybe I can use blue now. So here is an example. So what is the example? Let's be given two sets. The first set is S, and S contains 6 names. The first name is Omar, the second name is Fatin, and then Muna, and then Khaled, Yasmin, and finally Hind. Okay, let's consider a second set. Let's call it Beta, and this is the English alphabet. So Beta contains the letter A, B, C up to Z. Okay. Now let's consider the function f from S to beta. So the domain of the function f is S, and the codomain of the function f is beta, and f assigns to every name in S its first name, its first letter. So let's take, for example, what's the f of Omar? So it is O. What's f of Fatin? It is the first letter of Fatin, which is f. Okay, so here we have that Fatin is an element in the domain, and the function f assigns the letter f in the codomain. Okay, and so on. So f of Yasmin is y. Okay, and so on. Now let's find out what is the domain. What the domain of f is S, the set of the 6 names. Okay, the codomain of the function f is the English alphabet, the set beta. Now let's compute what is the range of f. The range of f is the set of all images of the elements in the domain. So what is the image of the first element in the domain? The image of Omar is O. the image of Fatin is F, the image of Muna is M, the image of Khalid is K, the image of Yasmin is Y, and the image of Hind is H. So this will be the range of F, and notice that it's a subset of beta, the English alphabet, the set of English alphabet. Okay, so B here is the example. Now let's have another example. Let's change the color. So look at the example. We have a function called G. Its domain is the set of integers, and its codomain is the set of integers, and it is defined by saying, so where if you choose an element, an integer n, its image under G is its square. So here notice that the square of an integer is an integer, so it belongs to this set. Okay, maybe we can I can say right here are the integers. So, and here is another copy of the integers. Okay, now what is the image of 0 is 0 squared. What's the image of 1 is 1 squared. What's the image of negative 1? It's 1. The image of 2 is 4. The image of negative 2 is negative 2 squared, which is also 4. Okay, now say here is 9. What's the image of 3? It is 9, and so on. Okay, so this is the picture, and you can say that, for example, G of 0 is 0, G of 3 is 3 squared, which is 9, and G of negative 2 is 4. Okay, now the domain of this function G is the first set, which is the integers, which is the same as the codomain of G. But let me remove this. Okay, now what's the range of G? The range of G is the set of all images of the elements of the domain. So the image of 0 is 0, the image of 1 is 1, the image of 2 is 4, the image of 3 is 9. Now the image of negative 1 is 1, it's already listed. The image of negative 2 is 4, the image of negative 3 is 9, and so on. You see that the range is the set of all perfect squares. So image of 4 is 16, the image of 5 is 25, and the image of 6 is 36, and so on. Okay, so this is the range of this function G. Okay, let's continue. Now we want to talk about special functions whose codomain is R, the set of real numbers. Okay, suppose that we have two functions. So I want now to discuss this point. Suppose that we have a function f whose domain is a set A and codomain is the set of real numbers, and another function G. So we have two functions f and g with the same domain and codomain. Now look, which means if you choose an element in A, its image will be a real number under f, and the same similarly for g. Now given these two functions, so given f and g, we can define new functions. For example, the first function is called the sum of the functions f plus g. So this is the notation for this new function. It has the same domain and codomain, and if you choose an element x in A, so where for x is in A, so choose an element in the domain, then the image f plus g of x. So this is the new function. The image of an element in its domain is equal to the following. First, find the image of x under f and the image of x under g. So these are two real numbers, and then add them. Okay. So this is the first function. The second is called the product of f and g. So we just write f and g. This is a function from the same domain, from the set A to the set R. So this is the codomain, this is the domain, where, okay, again, where for any element in the domain, we define the image fg of this element, so choose some x here, will be the product of f of x times g of x. So first compute the image of x under f, and then compute the image of x under g, and then these are two real numbers, and then multiply them. Okay, so this is one way where we can create new functions from old functions when the codomain is the set of real numbers, using this addition and the multiplication. Okay. Let's have an example on this. So, example, suppose that f, again, a function from R to R, where f of x is x squared. Okay, and g is a function from R to R again, where g of x is x minus x squared. Okay, so you see that this is a function, it takes an input x in R, and its image, the output, will be x squared. Okay, what is, for example, f plus g? What is f plus g? So this is the new function of 3. Okay, what is this? Okay, by definition, first we compute the image of 3, and we compute the image of 3 under g, and then we add these two numbers. Let's see, what's f of 3? F of 3 is 3 squared, which is 9, and then g of 3 is 3 minus 3 squared, 9. So this is 9 minus 6, which is 3. Okay, now f of g of 3, what is this? What is the image of 3 under this new function? This is the image of 3 under f times the image of 3 under g. So what's f of 3? Again, it is 9 multiplied by g of 3 is 3 minus 9 minus 6, and this is minus 54. Okay, so in general, let's find it. In general, f plus g of x is f of x plus g of x, and f of x is x squared plus x minus x squared, and so this will be x, where x is an element in the domain, it's a real number. And f times g of x is f of x times g of x, where f of x is x squared and g of x is x minus x squared. Okay, so if you want, this is x cubed minus x to the power 4. So this says that the image of x under this new function f times g is x cubed minus x to the power 4. So let me here say that it is maybe useful to think about a function f as a machine. Okay, you think of it as a machine which takes a as an input and produces b as an output, and b here is the image of a. Okay, so here a belongs to the domain and b belongs to the codomain. Now let's define the image of a subset of the domain. So we know that a function assigns an image to every element in the domain. So let's start here by saying, given a function f from A to B, and S is subset of A. We want to define what is the image of the set S. Look, this is the set of all f of A such that A is in S. Do you see what is this set? The image of a subset of the domain is the set of all the images of the elements in S. So the picture here is, this is A, this is B, and we have already a function. We are given a function, say okay. Now suppose this is our set S. Okay, we choose this set S. It's a subset of the domain. Then the image of S will be the images of the elements in S. So we have this element and this element. Their images is this set. This is the set of their images, and this is what we call f of the set S, where S is a subset of the domain. Okay. Note clearly that f of S is a subset of the codomain, and think about what is f of A. So A is a subset of itself. What is the image of the whole set A? So this is the set of all images in A, in the domain, and we know that this is called the range of the function f. Okay, I hope this is clear. Okay, what's next? Let's have an example on this concept, the image of a subset of the domain. Again, let's consider the function g from z to z, where g of n is n squared. Okay, the image of an integer is its square. And let S be the following set, say -3, -2, -1, 0, 1, and 2. Okay, and check that this is a subset of the domain Z. Okay, let's compute g of S. What's g of S? It is the images of the set of images of elements in S. So g of -3, g of -2, g of -1, g of 0, g of 1, and g of 2. But what is g of -3? It's -3 squared, which is 9, and then the image of -2 is 4, the image of -1 is 1, the image of 0 is 0, the image of 1 is 1, the image of 2 is 4. So this is 9, 4, 1, 0. The set containing these elements is the image of S. Okay.